Welcome back to another video. So from the previous video where we solved reversing linked list in recursive manner, this video we're going to be tackling this problem in an iterative way. So without using recursive calls, so it'll be much more space efficient, but it will involve manipulating pointers. So we have, let's say, 1, 2 pointing to null. This is a head. 1, 2. What we're gonna do is actually we're gonna have 3 pointers pointing to this guy, and then that guy. The reason why we need more than 2 pointers to swap around is because we need to also keep track of the previous one. So to reverse this one, let's focus on this guy, right? Focus on this guy. What we wanna do is have 1 point back to null, right? And then 2 point back to 1. This is the end result we want. But to do that, we first reverse this guy here. We cut this arrow and then point it back. So what we're going to do is to manipulate this one.next, which is this guy, to null. So one.next is pointing to null. But to do that, we need to keep this one in temporary variable so that we don't lose this guy. So we are cutting this connection here while reassigning one.next back to previous one. So that's why we're gonna have current point to 1 and then next point to 2 and then preb is short for previous, pointing to null. So this is a kind of initial stage where current is pointing to the head, and what we're gonna do is to first keep one.next, which is current.next, as temp. So keep 2 in temp. Basically what this means is that node next is current next. Keep it as a next. So here, so we're gonna do this until when, let's think about it. We're gonna do this until, so when current.next is null, then we hit the last node, right? So in this case, if it's 1, 2, 3, 4, right? How farther do we need to move forward? Current is here, we still need to go there, and if current is 4, and then current.next is gonna be null, that's when we want to stop. So what we're gonna do is have a while loop while current is not null. So we're gonna actually visit, go until the last node. That's how I like to think about it. Get to that last, like until we hit the last node, we're gonna proceed. So we construct a logic in a while loop here. So we're gonna have node preb is null, current is set to head, and then next is set to null. And then, all right, and then we're gonna have a while loop while current is not equal null. And then we're gonna save this one, next, current, next. So keep this guy as in a temporary variable, and then what we're gonna do is current.next is going back to previous. So current.next is preb, which is initialized as null in the beginning. right? And then after that, we're gonna basically increment preb to current, current to next. So basically we are sliding these pointers so that we move to next node. So preb is now going to be current, current is going to be next. That's it. So after first iteration, now new preb is this guy. Preb is now here, and then current is next, right? So we handle this already here, and then we don't have any connection right now here because we kept 2 in next, but we haven't done that, like connecting back. It's still pointed to null. So this is end of the first iteration. This is state 1. 1.next is pointed to null, and 2.next is pointed to null, and there is no connection. But we have this in the current, and the next current is not null, so keep next current.next is in the next. So now this is next, right? And then current.next is previous, which is 1. So now we draw this connection, right? And then prev is now this guy's preb, and then current is next. So this is gonna be current. At this point, next iteration, current is null. So we know we reached that last node. So what we're gonna do is return new head, which is this guy, which happens to be preb. So all we need to do is to just return preb. That's it. So we're gonna do some small test case. This first block is like when n is 0, n is 1, where n is a size of linked list. So we handle this already. This is the same as in a recursive solution. And after that, we can come up with a basic test case 1, 2, 1, 2, 3 as really small, like smoke test, like valid test case. And we have just done 1, 2. We could do 1, 2, 3, but it'll be the same thing. Basically, start with here, current is pointed to here, preb, here, null, and then next is going to be here. And then keep next, current.next 2 in the next. And then here, current.next is previous, so it'll be here, basically cutting this connection at this point. And then move here, preb, current, and next, next. And then the same thing, next is here, current.next is preb, so preb. So current.next, 2's next is here, preb. And then same thing, preb, current, next. Next is actually null, right? And the current is now 3. Same thing, next is null, and the current.next, which is current.next is used to be null, but it's pointing back to preb. Preb is 2, so now cut this connection and connect that back to 2. And then move forward, preb, current. Right, we are sliding the window. And then lastly, current is now pointing to null, so we are getting out of this while loop. And so that means we just finished reversing last node of the linked list. Previously last node, but it's going to be a new head. So preb is actually pointing to 3. And then now it's 3 pointed to 2, 2 pointed to 1, and 1 pointed to null. So we just successfully reversed that, and new head is 3, so just return preb, and that's it. So this is an iterative way to reverse a linked list. It is much easier, I mean, in terms of it's kind of like a linear way of thinking, as opposed to the recursive way, which requires bottom-up approach, which is kind of like involves stack and like reversing the order, which to me personally, when I was studying and then also studying for the first few years, took me a while to really wrap my head around. So iterative ways for reversing linked list is much easier in my opinion. And pointer manipulation is pretty important. Being able to think about it, being able to update and being able to debug this code using simple like test cases, which is really about messing around your head with pointers. It could be pretty complicated if it's like, reversing a doubly linked list. But today we're gonna wrap this up here. And next video, I want to talk about reversing linked list of size, like reversing every k nodes in linked list. So that'll be application of this one. So what we're gonna do next is 1, 2, 3, and if we were to reverse every two nodes, 1, 2, we want to reverse it like 2, 1, 3. If we 3, 4, then it's going to be 4, 3. 2, 1, 4, 3. So every two nodes we are swapping. It could be every 3 nodes, right? It could be like this, 3 nodes. So that would be a little bit more difficult, but just adding a few conditions and then handling some corner cases, it'll be super fun to solve this one because it'll give you so much confidence. Took me a while, for this one as well. So we're gonna solve this question together in the next video. So hopefully you review this question. If you had any ambiguity or confusion, make sure to go back to the video and slow down and understand. Maybe you can pause the video as well. Really understand this concept, pointer manipulation, 1, 2, 3. Also, we could do this in a recursive way as well. So we're gonna see you in another video. So I'll catch you guys later. So if you like this video, give it a thumbs up. If you have any questions, let me know in the comment section. Hopefully I can address some of the questions. And if you like this video, make sure to do that for me if you haven't, because that'll be my motivation to make another videos for technical coding interview question, so that we can ace technical coding interview questions for like Google, Facebook, Amazon, Apple, Intel, whatnot. So yeah, I'll see you guys in the next videos. Bye bye.